Good evening, everybody. I'm John Hoag. I'm an associate at Ohio University in a dedicated telecommunications program, and I'm adjunct at Case Western Reserve in Cleveland. And my talk is a little different in that I have really one point and one point only to make. It is really the advocacy that in your studies of big data that you consider all things infrastructure. Our craft has the amazing ability to make expensive equipment appear to run poorly. And so this is a concern that I'd like to consider. I'd like to spend 2/3 of my time on column A and 1/3 on column B. The scope of what I teach is telecommunications and networking. And if we expand this to where this overlaps big data, it would include all things compute and storage as well. And those are considerations apart from the analysis of algorithms per se. And the result is that the bottlenecks are not alleviated by throwing more cores at problems. And the ability to do in-memory compute is a short-term fix. And beyond that, you perceive Moore's Law as improved performance year over year, but the tricks in caching have about run their course. And so while this problem at a local level is somewhat abstract, what we're really seeking going forward is a very complicated, centralized, virtualized environment that if the ultimate scope of high volume, high velocity data is to interject big data kinds of analyses to data in flight on a transactional basis, the interaction between virtual servers and storage becomes its own bottleneck. And what I see in our craft is software-defined everything. Is that hardware is on a fast track for commoditization, and so with mobile actually driving so much of that we are seeing our next generation of networking to be commodity processor, terabit kinds of line cards, and open source software-defined management of the networks in order for your mobile device to keep its IP address and to move and to roam seamlessly on a virtual network. And the storage comes next. And so while the flexibility of software-defined storage is a benefit, it comes with some operational overhead to go with that. And so I don't think McKinsey has identified how many big data network analysts and server administrators one needs. But I think the importance of that kind of craft just becomes larger and larger over time. So that was the proposed presentation, and there's a paper to go with somewhere. The actual presentation, after I looked over what my colleagues were going to speak about, will point out that my domain is wholly science. We're not doing business informatics at either OU or Case. In fact, my 80-20 research agenda is 80% smart grid, specifically the 10 times per second voltage and frequency capture, which is nearly 500 million transactions per year for just a single device. And the 20% is bioinformatics, which is 3 billion base pairs per sample per individual. So that's kind of my footprint. We are at my home university rolling out a certificate program in this, and I do appreciate the insight from so many people here, and the workshops today. Those have brought back some very good, useful lessons as we continue our discussion on how to structure and how to partner going forward in our program. I have 2 slides going forward. I'll make a remark about at Case Western, their bachelor's in data science, because my chair could not attend today. We'll also point out that in the state of Ohio, and we can include Kentucky, northern Kentucky in that we have access to an NSF-funded supercomputer cluster, couple units with 10,000 cores each, and the part of all that is Ohio State University, my alma mater. Thank you. I was counting on that. So at the depth of how we study things, and I'll point out, you probably did not have a parallel processing issue to deal with on the Manhattan Project, but Mr. Feynman and Mr. von Neumann probably were unrolling loops in order to improve performance on all of what they were doing. The bottleneck tends to be the path to this any InfiniBand or iSCSI paths to storage, not processors. And where we're headed within my research team is to look at, well, actually there is no science of this. The literature for this is interestingly weak, in that I believe that as we move forward with taxonomy and ontology and even fleshing out the bibliography, that we'll be in a good position as a research community to contribute for those who want to do either real-time or transactional-based big data. And yeah, our discussions range into information physics and information entropy, because these are not specifically in the two use cases where I work, data that can be compressed. So it's the real deal. And as we're bootstrapping this, obviously anybody else who's interested in this should self-announce. Ken Leparo is my chair at CASE and EECS, and I will direct your attention to the bottom couple points, and then I will ping my colleague from Ohio State. They're rolling out a bachelor's in this. It is sufficiently vague, and this is just cut and pasted from the website. Obviously, it has presidential visibility and corporate visibility. I think the number for this is 2.6, and they're not building buildings with that. And at Ohio State, can you hand the mic back for just a second, and I'll cycle this. And I will offer to
Oh, I can definitely send something to you. Yeah, thank you. So my name is Chris Hans. I'm an associate professor in statistics at Ohio State University, and now the co-director of the university's new undergraduate major in data analytics. So it's been interesting to hear. I know CASE was kind of developing their program almost in tandem with us. Ours just started in 2014. It's interesting to hear a little bit about the Northern Kentucky program too. And President Snyder was the provost of Ohio State University before, so I know there was some communication back and forth, about these programs. But yeah, we've started an undergraduate program now in data analytics.
There's something between I-95 and the 101, and we have good resources and good people, and I will mention that OU is a cool place, and that right now we're looking at the nascent analytics interdisciplinary certificate, and I think for the most part our staff has great depth. And my home department has this Master of Information and Telecommunication Systems program, which is networking and telecom and the virtualization aspects. The certificate could ideally lead to an IE kind of program or math stat. I will point out last couple things that we own a med school, and they've received a huge amount of support from their community, and in the realm of translational biological sciences, we will have a very good position, both in a joint, not MD, but DO PhD program, which will allow the engineering and IT faculty to teach the med students and contribute to research. I think that's good synergy. And I will mention that finally that in the certificate program, it will recognize that people do have a home department someplace. And so the glue that holds things together will probably be, you know, an SPSS modeler class to get folks going, but a recurring seminar that would continue on. Again, this targeted at the grad level. So I guess I can pause for a question or two or none. Thank you very much.